Welcome, everyone. Hope everyone is having a phenomenal EDA day. I know I am. It's wonderful to see everybody here and in person, and there's been such an amazing lineup of talks so far, so wonderful to have you all here. So, I'm super excited to be presenting and just kind of lining up the talk here for Toli, who's going to take us all the way through the Cinch journey with event-driven architectures. My name is Emily Shea. I lead our application integration go-to-market team at AWS. Which includes a lot of the services that you probably heard about today: EventBridge, Step Functions, SQS, SNS, all those good ones. And I've just been super excited about the Cinch story since I first heard it, and so I'm really excited to get to kind of unpack it and go into it today. But first off, I'm going to start off just with a couple of the kind of key concepts and some of the background kind of concepts to understand as we get into it before I hand over to Toli. So, there are a bazillion talks out there that talk about your application's code. Writing the code, testing the code, deploying the code. We focus a ton on the code. But a question that I want to pose to you today is, what do you think about deleting code? Throwing it away, starting over with something new. I think this is a really fundamental part of being able to experiment and be agile in the applications that we're building. And so many people that we talk to are just really, they hold tight to that code that they have today, and maybe give up opportunities to try something new. So the reason that we want to hold tight to our code and we have this reflex of, I've built this, I want to keep kind of maintaining it and working on it, is because building a new feature and writing that code takes a lot of energy. You need to spin up that infrastructure. You need to write any kind of integrations or connect that piece of code that you're writing to the other pieces of code within your application. Another huge piece of it is just coordinating with other teams. So maybe there's other teams that are working on related microservices, and you need to make sure that your changes aren't going to impact them, or that they haven't made changes to their maybe APIs, and you need to coordinate around those. So that's a huge piece of it. And then lastly, you finally get down to the piece that you really intended to set out to do, which was write the business logic and actually deploy the feature. So a lot of that work is going into just getting any new feature out, and so it makes total sense that we're kind of concerned about deleting any code and being able to start over and try something new. So when I'm talking to customers today, I find that a ton of time is being spent on operating and maintaining the existing code that we have, and that really limits the amount of time they're able to experiment and have the kind of agile responsiveness to customer requests that you'd like to have. At AWS, with the services and the products that we're building, our goal is to take us all into a world in which the only code that we're writing is that business logic and getting features out the door. And the way that we think is super helpful to be able to do that is with serverless services and event-driven architectures. This really whittles down that list of things that need to go into a new feature being developed and leaves you with just the business logic piece. So quick recap of what is serverless. Serverless services are all about just uploading your code, never touching or managing the underlying infrastructure behind those. That infrastructure will scale up and down as traffic changes. And lastly, a ton of managed integrations and managed functionality that's built into those that you're not needing to code yourself. So what are some of the things that you're going to have built into serverless services? Thinking about connections between services, maybe it's invoking a Lambda function or sending an EventBridge event to another service. A lot of those are going to be built into the services right out of the box. Another amazing thing is that there's hundreds of AWS services that emit events by default. So if you're building an event-driven architecture, if you were in kind of a traditional environment, you might have to emit those events yourself versus just responding to them coming out of the AWS services automatically. There's also a lot of cool stuff that comes into services when we think about, for example, step functions and having that retry logic and error handling built in and not needing to build that yourself. It also, with step functions, has a lot of SDK integrations that will make API calls for you to different AWS services. And so that, and again, limits the amount of code that you're having to write, to test, and maintain over time. So there's a lot of things that you're kind of getting built into the services that you're not needing to write yourself. So we've talked a little bit about the serverless piece, just some of the benefits that we're seeing customers have as they're building event-driven architectures. If we take a typical microservice application as an example, maybe this is an eCommerce app with order, inventory, search, a lot of the different kind of common components we see. But when we look at this application, again, Gregor told us to remember the lines that go between those boxes that really define how it interacts. You'll oftentimes see this. So loads of direct connections, loads of different kind of connections that need to be written between different services, and that is a lot of kind of complexity that suddenly happening within this microservice application. One of the challenges with this is, say that one of those services has a new idea or a bug fix that they're desperate to get out, and they really want to, they have the code already written and they're ready to launch it. The problem is that they first need to coordinate with all of the teams that they have those direct connections with to be able to launch it and make sure that it's deployed safely and there's no risk involved with that launch. And that can take a lot of time and have developers kind of stepping on one another's toes as they're trying to get something out. With an event-driven architecture, what we do is we take those kind of direct connections away and put an event broker in the middle. And now you've got kind of centralized location for all of these services to be communicating. Now the services are only needing to be aware of the event broker and maybe the event schema or what's in those events that are being sent. And they're able to kind of free up that time and that energy to just focus on the features that they themselves are developing. Another really cool thing about this is, say that you have a new service idea using those existing events, you can build that right on top of those existing events. So no need to change any of the other services or really mess around with those at all. Just build brand new features on top of existing events, and those can be kind of completely their own development project. So the core benefits that we see with customers that are building serverless and event-driven architectures are the ability to decouple teams, not have teams needing to coordinate closely with another before launching something, freeing up that ability to experiment, and so losing that kind of need to hold on and not be able to delete any code, and instead be able to try new things all the time. And then fundamentally, all these things come together to allow you to build features faster and get them out to your end customers. And Cinch is an amazing example of that. So for anybody that's not familiar with Cinch, hasn't seen the taxis driving by or the billboards all over the place, they launched in October of 2020. They're a fully digital used car e-commerce site. Lots of different features like home delivery, payment financing, part exchange, all those different components built into the e-commerce application. And the amazing thing about this platform is that it was really built and launched in just 6 months. And the team, and Toli will tell you that a huge part of that was the serverless and event-driven architecture that's behind it. So some of the amazing things they were able to achieve, the scalability of the platform with requests exceeding 1 million per minute, and actually latency going down as the load increased the application. Also moving from a Kubernetes-based environment to serverless services reduced the total cost by about 30%. And then hugely that agility piece that we've been talking about teams being able to move so much faster and own the entire stack for the microservice that they're working on. And finally, I think the really cool thing is that all of this kind of agility and ability to experiment really accelerated the business's growth, allowing them to achieve a 10x conversion rate of people coming to the site and making a purchase in just the first 12 months of the platform. So with that intro, I'd love to welcome up Toli to take us through their journey.
Thank you. Right, thank you. Thanks, Emily. When Emily reached out the first time to say, to ask us, would you like to tell the Cinch story, I was very excited and very happy about this, because we went through a journey that was very steep learning curve, very aggressive deadlines, and we had a lot of learnings. And what I'm going to try and do today is try and confirm a bit of the stuff that Emily's talked about and give you guys our experience on this. So, first of all, who am I? Engineering practice lead at Cinch. What that means is I work with teams to continuously help them continuously improve their engineering practices, especially with a DevOps mindset and a bit of a focus on observability. So I'm half British, half Greek, specifically Geordie, basically County Durham. That's a bit of a middle ground. Don't know if anyone from County Durham here? No, okay, good. So you're not at Macam, you're not at Geordie, you're something in between. Anyway, I started out in maths and mathematical physics, and I got into software a bit later on. And I played basketball professionally, and since I stopped all that, I'm doing a lot of yoga. So that's about me. I got into software by being hired as a mathematician to write algorithms for a scheduling system. And I learned to become a software engineer over the years, and I've been a software engineer, well, I've been building software for the last 10 years or so. Why am I saying this? Well, when we first started, this was Cinch. In one room, the entirety of Cinch, and I'm there. Luckily not wearing the same stuff, same top. But that was literally everyone. And towards the end of 2019, we were starting to build a team in Manchester. The challenge we had was, can we deliver an e-commerce platform that Emily was talking about in more or less 6 months? When we say 6 months, in April, that's who we were. We didn't have more people, so we were actually hiring people as well. And we wanted to deliver in September, remember, in heavy lockdown, in the pandemic, and all this. But we didn't want to just deliver and then forget. We wanted to deliver and then accelerate. That was very, very important. So we wanted to still use the same architecture. We didn't want to kind of necessarily throw everything away. So fast forward to 2022, we're still evolving with the existing architecture. So we had 3 considerations to start with. We're going into an industry, the automotive industry, and we want to disrupt it, and we make a digital experience that's very different to what we had up till then. And how do we do it when they have different tech stack, different engineering practices, and how do we integrate with these without affecting our customers? How do we build momentum, but then keep that momentum? Very important. And how do we avoid building stuff that we don't really need? That was probably something, our biggest realization. We wanted to be hyper-focused on product. How can we make a great product? So for that, spoiler alert, we chose AWS, serverless, and event-driven architecture to satisfy those 3 considerations that we had early on. First question, why serverless? Emily talked about some of the benefits of serverless, but we looked at what you might want to care about. And we actually inherited a heavily containerized platform in the form of Kubernetes and Docker. Everything was Docker containers, and it was perfectly fine. Really good system, built by an agency, but we didn't want to do any of that. We didn't want to care about Kubernetes clusters. We just wanted to think about our application. And the reason for that is because if you think about what you might care about fault tolerance, security, scalability, these kind of things. We wanted to outsource all of that to AWS, happily. They can maintain it, they can think about all the scalability, and we just focus on using the platform. We just wanted to use, so we chose serverless for that, because we just wanted to use the platform. We didn't want to be thinking about things that would distract us from our goal. Second question, why event-driven? So if you think about, there's many benefits for event-driven, and I'm going to call them event-driven, but with APIs, you have a commitment, you have a contract that you're going to have a performance that's going to be generally up, that it's going to respond in a timely manner. And you also have an interface contract, so you think about REST APIs, they don't break, you kind of commit to that so your consumers can use them. With events, you outsource the performance SLA, again, to AWS in the form of EventBridge or serverless, and you don't care, they handle that. And the only thing you care about is the interface SLA, so in this case, EventBridge event. So hopefully that makes sense. Just to kind of, one thing that I want to maybe do today is from the keynote, there were some questions posed, and hopefully we can answer some of those questions, even if it is loosely. So the things I'm going to go through is what do our systems look like, what are the teams, what's the tech stack, so we can get context. And then the critical bit is about what patterns emerged and how we evolved from those patterns. So first of all, systems, teams, and tech stack. So think about the user journey of a car buying platform. You need to search for a car, you need to pay it or apply for finance, you need to order, you need to deliver a vehicle at their home, and you need to do some post-order stuff, but also, critically, you need an inventory of cars, because otherwise you can't sell cars, right? And we start building teams, cross-functional teams behind each of these systems. That's the first thing we did in 2020. We started building that. That April 2020 that I was talking about, that's what we started doing. And we used, as we alluded to, serverless, so Lambda, specifically Node.js. We used CDK. We actually used serverless framework first, but then when CDK became more mature, we quickly adopted that. And we chose TypeScript because our front end was already TypeScript, and that made loads of sense to have the same language across all stacks, front end, back end, and infrastructure. We use DynamoDB for our storage. This is a link to a couple of blog posts that we used from Adrian Hesketh, which was from InfinityWorks, which was our kind of partner consultant. It helped us a lot with skilling us up in the expertise and giving us the initial patterns. Not going to talk about this too much, but it's worth mentioning it. EventBridge, I think, launched in 2019. we started thinking about Cinch in 2019, so it was kind of a match made in heaven. We thought, okay, we'll do this. We'll go all in with a serverless event broker. And finally, it's worth mentioning that we use SQS. I'm not going to go through it too much, but 3 things we kind of more or less used it for: dead letter queues. Yes, because Brits love to queue, and I'm British, so I can do that. I can do some humor there. Buffering data and first in, first out, and exactly once delivery, which there's some nuances to that. Again, won't get into it, but it's worth mentioning it. So what does a team own at Cinch? Well, we have a collection of lambdas that form a component, a microservice, if you like. And there's a number of single-purpose lambdas and we have a Dynamo single table. More or less, if you abstract it, that's what a component has contained inside it. And there's any kind of trigger, an AWS trigger or another event bridge event would start the process, store some data, and then publish a domain event to the shared event bus. That's basically a schematic approach, a drawing, like was said in the keynote. And we also use SQS for DLQs. If you scale that out, like Emily was saying, you can go from having a component publishing to a shared event bus and another component consuming from the shared event bus. Obviously, components can both publish and consume, but just for schematic approach, for kind of demonstrating this, this is the relationship. And then that scales up with components publishing, components consuming, and using the shared event bus as the integration point. Quite early on, we actually used partner event buses as well. An example is Zendesk, and we integrated them into our shared event bus, and the same flow continued. So that's our teams, our systems, and our tech stack. So let's get into the beef of it, which is the patterns that emerged. So rather than talking about all the systems, I'm going to focus on search and inventory, 2 systems, and how they interacted throughout the rest of the talk. What search looks after, if you've gone to any kind of standard search a car website, looks after this page, basically. You can filter, you can search on the free search text search, and you can look for the car that you want. Inventory actually does 2 things. It looks after the car information, but also the car status. And you can view the car details on the website. So if you click through on one of the things on search, you go into the Vox and Twig one, and you see all the details that you need. Now, this was very important. We wanted to offer a digital experience, and this is the actual car you're buying. It's not a representation of the car. And we wanted this to be a very deep, strong experience, and you get all the information you need to buy the car straight away. What inventory does, just to give you that context, it's an aggregator of the car's state. So it'll take external data or internal events, aggregate the data, and publish events with a state of the car. Examples, it would consume events like vehicle acquired, vehicle sold, vehicle delivered, and it would publish events like vehicle imported, vehicle published, and vehicle updated. So these are kind of real examples that we use. I'm going to focus a bit more on this event because that's very, very interesting, and I hope you can take some takeaways from this. TLDR, inventory component, asynchronously powers both the search page and the vehicle detail page. So the big question, how do these 2 systems interact? Inventory component takes all the external data or other domain events, puts an event on shared event bus, search component responds to that, and ultimately that information gets on the website. This is the first pattern that we kind of noticed, and I called it the event ledger pattern. By the way, all the patterns that I'm kind of talking about today is not patterns that I suggest everyone should do. It's more things that we noticed. So what the event ledger pattern is ultimately you have any trigger on this side, a Lambda responds to it, writes domain, event, and state to a single table. On state change, use Dynamo change streams, you publish a domain event to the shared event bus. Now, when we first started this, we didn't use Dynamo change streams, and that caused some issues with atomic operations. So you might store something in Dynamo, and then it doesn't get published in the shared event bus. So that's a problem that you need to solve. So Dynamo change streams really, really help with that. So ultimately, one of the benefits of this pattern is that you can store and forget with Dynamo change streams, and you can outsource that consistency to AWS, which is great. And one of the things that we did very early on, because we're learning how to do EDA, right, is publish events by default. So whatever we did, we were publishing events to this shared event bus. As a result, the things to consider that we kind of started noticing is that because we were hiring people that had CRUD experience, they were not familiar with these EDA patterns. So a lot of the things started leaking some CRUD maybe patterns, if you like. So it's hard to kind of understand this pattern and such and execute it. With the events, because we wanted to share everything, we did expose the database schema to an extent in the events themselves. And I'll show you a bit about what that means a bit later on. And we also mixed private and public events. So some events were never, ever going to actually be consumed by another component, another team, another system. It was always going to be consumed by the same system. So that was a bit confusing for the teams. And finally, we mixed event and state store. So one single table had both the events and the states. If you look at that pattern that I talked about earlier, you'll get the details of how we did that. So, critical question, how are we solving this? One of the ways we're solving it, because we have other ways as well, is we use this dual event and state store pattern. So we would write an event to an event store, a single table, and then another change stream another Lambda would write state to the state store. So have completely separate Dynamo tables, and again, publish the main events off the back of that. Event store really does help with debugging. I think that was mentioned earlier on as well. This pattern just generally has a consistent and stateless flow of data. It fits in people's heads, people understand it, there's a clear separation. And it's an interesting effect that this state store has, which is it becomes more of a cache sometimes when you want to go and grab some data, the latest state, you can get that quite easily. And ultimately, the state store almost serves as a presentation layer as well for your API or your front end. So we went from the event ledger pattern to the event state store pattern. And this is not we didn't do it for all systems, but this is more or less something that we noticed. So going away from inventory, so again, we've got this example of inventory and search. How do we share vehicle updates? How does inventory, as an aggregator of events of the vehicle, how does it share these updates with other systems? And this is one of the biggest pattern that we noticed earlier on, what I call the GOTO event pattern, and actually we call it internally the GOTO event pattern. And what that means is that inventory does its stuff here, as I said earlier, and it published a single event called vehicle updated. As you can tell from the name of the event, it's not very specific, it's not very contextual. It contains the latest state of the event. It's a general purpose update event, and it has all the state about a vehicle. So whatever you need, it'll be in there. Last time I checked, it had 80 plus fields, and the contract never breaks. It's something that's always there. You can rely on it. And because it was mentioned earlier in the keynote, this is more or less, I think, an event carried state transfer, which I can never remember the name of. There's a lot of words there. Example. So our event would kind of look like this. You would have information about the car, things like the color, the make, the model, number of doors, things like that. But it'll also have information about the car status. Is it published? Is refurb complete? What's the kind of spec data status? Things like that. But you'd also have information about the metadata, about the event, so metadata, so event source and event version. And this is the implementation detail that we leaked, which is around the vehicle ID. And so information from Dynamo, really. Now, so this is what the pattern looked like. You would have a vehicle updated, and that would be used consumed by search components. But then other components would also use it, like the orders or delivery or finance would also use this event, because it builds a rich view of the vehicle from very diverse sources. It publishes all the things vehicle in a single event, so all you need to do is consume that event, you get all the information you need. And it indirectly defines many states and many reports across Cinch. So there's positives to this pattern. You can trust you'll find whatever you need. You don't need to hit an API. It's like the fat event, if you like. And it becomes the only integration point between systems. The inventory and search, the only thing they need to talk about is this vehicle updated event. And at the time, we're scaling a unicorn. So as we were moving really, really fast, this really, really helped. We just talked about vehicle updated event and other events like this, and that's it. Considerations. An important one, we were talking about this with Emily earlier, that the component and the team, in this case inventory component, becomes an accidental proxy of information. What that means is that inventory may be getting the information about whether the car refurbishment is complete from a further downstream system and including that in the event. And then these components were actually using that information. But what if inventory didn't want to publish that information anymore? It becomes this kind of it becomes responsible for that information without necessarily wanting to or being intending to. So as a result, components coupled with many components for many reasons because of this God event. And change becomes hard. You can't really change things because there's loose coupling, but also quite a bit of coupling as well. It's a bit weird. And when it's used by reporting systems, you are really stuck because they really rely on this God event. So how are we solving this? There's no kind of pattern that we're going to necessarily, but the number one thing we're doing is we're thinking about more specific and contextual events. So as an example, we have vehicle price increased from the pricing component or vehicle valuation decreased from the valuation component. And these are in addition to the vehicle updated that's still there to be backwards compatible. One of the side effects of this is that we ended up having smaller components built up because the result of having this God event was that inventory components started becoming really, really big because it wanted to serve this big event. So there was a direct correlation between size of component and size of event. To give you an example of a more contextual event, Inventory started publishing listing updated, which has 4 fields, and the event is published when a vehicle's price or published status changes. And that's it. You have 4 fields, and it's a lot smaller and thinner and contextual. But other than thinking about kind of smaller contextual events, we're also trying to think about contract testing between components. So the consumer to try and keep the publisher a bit, keep their accountability. So are you gonna make sure that this contract doesn't break? And I want the test to break if that's not the case. And the second thing we're doing is a general kind of exercise of rationalizing about events, thinking about naming conventions, thinking about the structure of events, because we don't have that in place right now. But, as you might see from other talks today, there's a big thing about, it's not only technical solutions that we need to look at, there's also more socio-technical solutions. So when we first started out, back in April 2020, we did a lot of domain-driven design practices. So we did things like event modeling, and there's some elaborate event models that we've used. But then we kind of went away from it. And that started to show in our architecture. So we have people internally at Cinch who are really, really good with domain-driven design workshops. So we're starting to build up our practice around domain-driven design. Second thing we did is a bit of a technical, but also socio-technical impact, is that we built out a Cinch backend template, a starter pack. I think someone mentioned it in the talk earlier, whereby you can create a component quite easily with kind of some defaults that you don't need to think about. Because that was one of the things that we had a lot with, I don't know how many people use Node here, but there's a lot of plumbing that you have to do to start a component, and that was a high bar for entry. So we lowered the bar for entry. As a result, we had a lot more smaller contextual components. And it also served as a blueprint. So what that meant is that if you, in the template, we might have a bit of a nudge to event-driven practices, event-driven design. And finally, we're looking into using a central place for documentation of events, and we're using Backstage. Backstage has evolved quite a bit since it first launched by Spotify, and we're looking to get all the teams on Backstage so that they can self-serve. So that's it. That's the God event pattern. That's what we kind of noticed, and the pros and the cons, and how we evolved. Question now is how do teams consume this God event? What does that look like? Well, initially, I was part of this team actually, Search at the time. Search Inventory had a lot of chatter going on. We literally, in our chat tool, we had a Slack channel called Search Inventory. There's a lot of conversation. Can you include this in that event? Of what do you need from this? All sorts of conversation. And that was a bit problematic to start with. But ultimately, Search actually consumed loads of events, one of them being from Inventory. It would validate and parse these events, and then it would write the state to a shallow copy of vehicle state in Dynamo. And then every minute, there would be a Lambda that would load the vehicle get the latest vehicles from Dynamo, load the vehicle snapshot, and store it in S3. So we started very, very lean. We didn't want to have elaborate solutions. We wanted to get the data in the most leanest possible way. And ultimately, users would browse the website, hit API gateway, hit a Lambda. The Lambda would fetch that snapshot. Within the memory of the Lambda, we'd sort and filter. We only had about 5,000 cars at the time when we launched, so that was easily done. And that was our lean approach to consuming the event and ultimately getting the cars for our customers to browse. So those are the patterns. One of the big things about EDA is that you can evolve it, and you can evolve it quite in a decoupled manner. So one question you might have is, how do you extend this system? If you try and buy a car, what was happening early on, you'd find the car you really want, you would go through, get to checkout, and only to find out that someone else had reserved that car because they were in the process of finance application, or they were doing checkout at the same time, but they got there first. So we want to kind of bring that further up in the funnel and tell the customer that, well, this is reserved, don't click through, don't bother. And essentially add this tag. So how do we do that in an event-driven way? Well, going back to the inventory search pattern, you have vehicle updated, published, search consumes vehicle updated, it builds this vehicle snapshot that we talked about, and ultimately surface the cars in search. Well, to surface this information, you would consume a vehicle reserved event from a different component, build the vehicle snapshot and vehicle reserved status included in that snapshot, and then surface the cars with the vehicle reserved status as a tag. There we go, done. We've done the feature, and easy. There's nuances to that and complexities, but that's more or less the pattern that you would follow. Second question is a bit more socio-technical. How do we evolve this system? How do we evolve the architecture and the teams? The initial thing that was happening, that we had, is that we had search and filter for cars that was looked after by search, and then we had inventory of cars and what we call internally the full page ad for cars looked after by inventory. So what was happening there? So inventory was publishing vehicle state for anyone who might care, but it ended up considering the presentation layer for search, so all that chatter that was going on. And search has control of its own data, but it has to consume loads of events, which is problematic. Or you might say it's the right thing to do, but search had to think about a lot of complexity. So for that reason, we launched a different team who would look after the full page ad for cars, called vehicle detail. And inventory would still have a website to look after. This is an internal admin website that they look after for sourcing vehicles. But vehicle detail will take over the vehicle detail, as you'd expect, page. So how that would happen, you would literally go from inventory vehicle updated to vehicle detail, vehicle state updated. That's literally the transition that you go through. So rather than search consuming vehicle updated, vehicle detail would consume it and then publish a vehicle state updated that then would be consumed by search. So decoupling search and inventory by doing this. And what that would look like, that would end up becoming this lazy consumer pattern, which is an interesting one because ultimately you would say that actually what search was doing earlier was the right thing, but what they wanted to do is they wanted to consume this single event. Just give us the vehicle state updated, and this event was a lot closer to what they wanted for their presentation layer rather than what was in inventory. So the pros for this lazy consumer pattern is that you would only care about one event. Search would only speak to one team. It would be coupled, but it would be coupled with a more suitable team. And it could ultimately focus on what makes them awesome. Example for that. No, not example for that yet. So considerations. Search, or in this case, doesn't control its own destiny. It relies on documentation being up to date, and it has to translate data from inventory to vehicle detail. And there was a consideration of what if the event stops getting published, but that would all be dealt with in an event-driven way. How are we solving this? Again, contract tests, documenting events, again with using Backstage. And for those of you who know me, I couldn't go through a talk without mentioning observability. We're very big with observability. I think we have quite a mature practices and tool set. So we do the same with events. If an event hasn't published for a while or it hasn't been consumed for a while, the teams generally know if that's the case. We trust AWS to do the right thing and EventBridge to do its thing, but we might be doing something wrong, and that happens, so we have really, really good observability, so we know about that early on. So what did this mean for teams, this socio-technical thing that I was talking about? We went from inventory and search to this inventory, vehicle detail, and search pattern. And we did that in an event-driven way, and it only took us a few weeks to do it. Benefits. We can focus on inventory, but inventory gets a new consumer. Vehicle detail has control of its own data, but accepts complexity in favor of consumers, in this case, search. And for search, conversations and events reduced to one, a lot less complexity, but it relies heavily on vehicle detail. Ultimately, inventory could focus on the car and its status. Vehicle detail had ownership of its own car detail. And search could focus on making search awesome. And this is where I've got an example, a product example. Search made filters awesome. So filters, when you select a make, then it gives you the number of models, the number of models for each model there. So what they did here, remember the S3 pattern, so fetching the snapshot from S3, they took the time, so they reduced the complexity with consuming the event, and they took the time to actually build out an Amazon Open Search pattern so they can do some advanced faceting stuff. Right. Those are the patterns that we observed over the last 2 or 3 years. My conclusion. So we chose Serverless EDA and we ran with it. We literally just started building with the help of InfinityWorks as a consultancy. We evolved our systems with very little friction, and EDA and Serverless EDA enable teams to be autonomous, that Emily was talking about, and move at pace. We were literally able to do that. We built an eventually consistent decoupled system to protect our customers from third parties or other components within Cinch. A critical one for me is that everyone at Cinch talks about events. They don't talk about APIs, they don't talk about resources, they talk about events, and they become our protagonists. And we only need an interface contract. We don't need to care about performance, especially because we're serverless, but because we're EDA as well. I think Emily mentioned this, but ultimately we did scale without having to manage much. Interestingly, serverless and EDA gets quicker the more it gets used, and it costs a lot less than the container solutions that we adopted. So, talked about 4 patterns: the event ledger pattern, the GOTO event pattern, the event state store pattern, and the lazy consumer pattern. If you take anything away from these patterns, I would say that for event ledger pattern, maybe think about separating the store. Do something that makes it easier to fit in developers and teams' heads. With the GOTO event pattern, think about smaller, more contextual events. Would we do it differently if we started again? Maybe, I don't know. The GOTO event worked for us, but if you can learn about EDA quickly and have good documentation early on and have good designs early on, maybe it's worth doing. With the event state store pattern, use dynamo chain streams, absolutely outsource that complexity to AWS. And with the lazy consumer pattern, I think this is very interesting, and it's probably my takeaway from this conference, is that be intentional with your trade-offs. You don't have to be doing the right pattern. It's about reducing the complexity, reducing the cognitive load. Think about your trade-offs of the option of the solution that you're designing. And with search, it meant that they could innovate in a space where they make a difference. Ultimately, events are simple, they're declarative, they serve as a data transfer mechanism. System is extensible, and crucially, teams like it. No one says, oh, why are we doing all this event-driven stuff? But I'll leave you with one last thing, and it kind of ties into what Emily was saying. It doesn't really matter, because ultimately, event-driven serverless systems allow you to experiment and evolve, and we've experienced that. We've evolved our systems. You can make mistakes, but you can recover for them. It's not a massive upfront investment. The only thing I would say to think about is think in events, be deliberate about their design ahead of time if you can. Put those practices in. And finally, I couldn't agree more with what Emily said. Throw it away and start again. Maybe start thinking less about refactoring and more about, can I throw this entire thing away and start again, subscribe to consume a different event, do something different. That's it. Thanks very much. And